Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC U1283, indicates a communication failure between the Power Tailgate Control Unit and the Microprocessor Integrated Control Unit, MICU, specifically linked to the Raylock SW frame. This can prevent the power tailgate from functioning correctly, which is a significant feature in the Honda Odyssey. The affected components include the Power Tailgate Control Unit, situated typically in the rear area of the vehicle, near the tailgate, responsible for managing the opening and closing of the trunk. The MICU, located in the driver's area, acts as the central communication hub for various vehicle electronic systems. A loss of communication usually suggests issues with wiring, connectors, or the units themselves. Understanding how these components interact within the Body Control Area Network, BCAN, is crucial for troubleshooting this issue effectively. DTC U1283 signifies that the Power Tailgate Control Unit has lost communication with the MICU. The Power Tailgate Control Unit is integral for the operation of the automatic tailgate function, allowing for the convenient opening and closing of the rear door. The MICU functions as the brain of various electrical functions in the vehicle. If communication is disrupted, users will notice that the tailgate may not work as expected. The Power Tailgate Control Unit is typically located near the tailgate area, while the MICU is found under the dashboard, making them relatively distant from each other. A clear understanding of their locations is essential for effective troubleshooting and repair in the Odyssey. There are several possible causes for DTC U1283. Wiring issues are one of the most common culprits, potentially arising from frayed wires or poor insulation that disrupts communication signals. Additionally, problems with the connectors between the Power Tailgate Control Unit and the MICU can lead to intermittent failures or total communication loss. Dust, corrosion, or loose connections can adversely affect connectivity. In some cases, failed components themselves within the Power Tailgate Control Unit or the MICU may be the root cause. Identifying the exact cause will require methodical testing and examination of all related components in the circuit. Symptoms of DTC U1283 typically manifest as the tailgate being non-functional, preventing the driver from utilizing automatic opening or closing features. Often, the vehicle's onboard diagnostic system will display the DTC U1283, indicating a need for immediate attention. In some cases, users can experience other coinciding electrical issues, as the MICU regulates multiple functions. These electrical problems may range from inconsistent lighting, failure in other body components, to an overall lack of system responsiveness. Recognizing these symptoms can help streamline the troubleshooting process and provide insights into the overall health of the electrical systems within the Honda Odyssey. The first troubleshooting step requires clearing any existing diagnostic trouble codes using the Honda Diagnostic System, HDS. This system allows technicians to erase the DTCs from the vehicle's memory, thereby resetting the system. After clearing, turn the ignition switch to the lock position and then back to the on position. This action reinitializes the vehicle's electronics and makes it ready for recalibration. It is essential to wait at least 6 seconds before moving to the next step to ensure the system has completed its cycles. Finally, check for any reappearing DTCs. If U1283 appears again, it indicates that there are persistent communication issues needing further investigation. In the second step of troubleshooting, turn the ignition switch to the lock position and then back to the on position, or simply press the engine's start-stop button to switch to off mode and subsequently back to on mode. This operation is necessary to refresh the vehicle's electronic system and ensure it is working correctly after any previous DTCs were cleared. A delay of at least 6 seconds is essential to allow the system to stabilize any settings before progressing further. By performing this step, the technician can prompt the vehicle to re-establish communications with the Power Tailgate Control Unit and the MICU. It sets the groundwork for the next critical troubleshooting procedures. The third step is to check for DTCs again using the HDS. It is crucial to determine if DTC U1283 is still being reported after cycling the ignition. If U1283 is still indicated, it confirms that the communication problem persists and further action is necessary. If the code does not appear, the issue may be intermittent, indicating that the systems were functioning correctly at that point in time, which could point towards loose connections or intermittent faults in wiring or connectors. Identifying these types of problems often requires thorough visual inspections and testing methodologies to pinpoint potential glitches in the system. The fourth troubleshooting step involves selecting the BCAN control unit's information from the Body Electrical System select menu within the HDS. This functionality allows technicians to check all connected control units, giving insight into the communication network. Verify if the rear junction unit is detectable by the system. If it is detected, this indicates that part of the communication circuit is functioning effectively, and you would proceed to check deeper into the communication paths to isolate the issue specific to the Power Tailgate Control Unit. If the rear junction unit is not detected, it suggests a significant failure in the BCAN system, necessitating further examination of wiring or connection integrity. This step requires measuring the voltage between the body ground and the rear fuse box connector B36P, specifically focusing on terminals number 4 and number 29. This measurement will allow you to verify if there is battery voltage present at these terminals. If battery voltage is present, this indicates that at least the power supply circuit is functioning correctly up to a certain point. If voltage is absent, it directs attention to potential electrical issues upstream, such as blown fuses or breakpoints in the wiring. Accurate measurement is critical, as incorrect values could lead to misdiagnosis and unnecessary repairs in the troubleshooting process. In this step, check the number B16 10A fuse located in the underhood fuse relay box, as well as the number C10 7.5A fuse found in the driver's underhood fuse relay box. These fuses are crucial because they protect the circuits that power the Power Tailgate Control Unit. If the fuses are intact, it indicates that the circuits themselves are generally functional, and further diagnosis into potential opens or high resistance points in those circuits is necessary. Conversely, if any of these fuses are blown, they must be replaced to restore power. Should the replacement fuses blow again, further investigation for a short to ground in the circuits becomes critical to prevent repeated failures. The final troubleshooting step is to measure unique voltages again between body ground and the rear fuse box connector B36P for terminals number 16 and number 26. This check is essential to confirm that voltage is present at these points, which feed back into the Power Tailgate system. Assessing these specific terminal connections can help reveal configuration failures or improper wiring that might impact the unit's performance. Each terminal must be measured individually for voltage confirmation to conclude the testing process correctly. Accurate readings here will clarify if further repairs, such as reconnecting wiring or replacing components, are necessary based on the results. Once repairs have been made based on the preceding troubleshooting steps, it is essential to conduct a final repair verification. Start by testing the power tailgate function to ensure that it operates smoothly and as intended, verifying that it opens and closes correctly in response to controls. After confirming functional operation, reinitialize the HDS to check for any remaining or reoccurring trouble codes. It is crucial that DTC U1283 no longer appears, as this verification step ensures that all issues have been addressed. Moreover, a complete systems check should be performed to confirm the operability of all related functions, securing the overall performance of the Honda Odyssey. To prevent issues such as those leading to DTC U1283, proactive and regular maintenance of the electrical systems is critical. Conducting routine inspections of wiring and connectors can help identify any signs of wear, fraying, or damage before they lead to failures. Ensuring that connectors remain tight and free of corrosion will bolster the reliability of electronic components, particularly in areas susceptible to moisture or debris. Additionally, if any protected wiring systems are exposed during repairs, it is beneficial to check and replace any deteriorated insulation. Implementing these preventive maintenance practices can diminish the likelihood of communication failures, enhancing the longevity and reliability of the vehicle. In conclusion, DTC U1283 highlights a significant communication failure between the Power Tailgate Control Unit and the MICU in the Honda Odyssey. Understanding this problem entails recognizing the roles and locations of each component in the circuit, emphasizing the need for thorough diagnostics to pinpoint issues effectively. The troubleshooting steps provided lead to a systematic approach, ensuring potential causes like wiring, connections, or component failures are addressed. Furthermore, regular preventive maintenance can significantly reduce the frequency of such DTCs by fostering a system that is less prone to electrical failures. By actively maintaining and monitoring these components, vehicle owners can enhance the performance and reliability of their Honda Odyssey. Please like and subscribe to the channel. See you next time.